Here. So electromagnetism is a fundamental part of physics and engineering. So it involves the study of the electromagnetic force. It's a type of physical interaction that occurs between electrically charged particles. So how this is a physical interaction means, so what is the between the fundamental particles? So what are these fundamental particles between electrically charged particles? What are these are electrically charged particles are fundamental particles. What are these? Already we know: neutron, proton, electrons, positron, like this. So because of this force, what is that electromagnetism force? Electromagnetic force is not only pervasive in our daily life, but also underpins the behavior of electrons and photons at the atomic level. Right, at the atomic level, that's the basic level. And we can show the electromagnetism, some particular figures here. What is the history of electromagnetism is early discovery. Thales Meutius observed static electricity in 600 BC. In the same way, Maxwell's equation, James Clerk Maxwell undefined magnetism and electricity in 1861. Modern applications, those are today magnetism underpins technologies like electrical power and wireless communication. Yes, right. Because of wireless communication, because without using charger power cable like this, so through wireless also we can charge our phones here. If they are taking some advanced technology, that means simply I just plug it to the particular socket and I kept phone in my hand, then automatically if I switch on without wire, the charging will be powered in the particular phone. That is some wireless communication, wireless technology we are using for the charging phone also like this. Because of this electromagnetism, it will be developed. In the same way, key principles, those are electrical charge describes the various properties of atomic particles. What are the atomic particles? Those are some subparticles like electron, proton, neutron related to the electrical charge, whatever may be related to the particular electrical charge. Similarly, magnetic fields refer to the magnetic influences of electric currents and magnetic materials. So refers to the magnetic influence of electrical currents and magnetic materials. Magnetic influences, it will shows particular magnetic influences. So those are some magnetic fields. We showing that particular influences that have some magnetic fields. Right, in the same way, electromagnetic induction, the process of generating an electromotive force, that is what the EMF, already you studied about that EMF. The process of generating an electromotive force by changing magnetic fields. That means simply like a fan, the wings of a fan, I'm just rotating 3 magnets parallelly in a high speed, then it produces a magnetic field which produces some electromotive force. So because of this particular electromotive force, there is some magnetic induction is there. That is nothing but electromagnetic induction. Like this, the process of generating an electromotive force EMF by changing magnetic fields by rotating or maybe fastly moving parallel like this, right? And applications of electromagnetism is, what are the main some appliances here? It is mentioned that first one, electrical motors is the by fast rotating of magnets, it will be happens, these appliance will works. And then and also second one, transformers and wireless communications, generators, magnetic resonance imaging, MRI, like MRI scan like this, right? You can see in number of shopping malls. So like this, magnetic resonance imaging and particle accelerators. You can see that a particular thing in a accelerating devices like a game in the gaming or like this, right? You can experience these particle accelerators, right? In the same way, magnetic fields in nature. What are the magnetic fields in nature? That means first one, Earth's magnetic field generates the magnetosphere, protects the atmosphere from the solar wind. Yes, because of the magnetosphere, so Earth can be protected from the solar wind, right? So because of the Earth's magnetic field generates the magnetosphere, protects like a blanket in the atmosphere from the solar wind, right? In the same way, magnetic fields in astronomy play a crucial role in formation of stars and galaxies. Yes, because of the magnetic field only, all will be developed and all will be rotating each other. other else it may be collapsed. So these magnetic fields in astronomy means in the space, so play a crucial role in the information of stars and galaxies. Similarly, magnetic fields in biology, some organisms like birds use Earth's magnetic field for navigations, right? For example, if we take in some migrating birds, వలస పక్షులు అంటాం. So those are they can be keep remember their own way. How can we transfer from maybe from continent to another continent because of the navigation system it have. So how this navigation system means it can be recognize and detect the particular magnetic fields and magnetic lines and magnetic field produced by the earth. So by taking that particular fields, it uses it as a navigation to follow its own way. By this it can be transferred from one continent to another continent. Like this, some organisms like birds use earth's magnetic field for navigation also. Here some organisms like birds use earth's magnetic field for navigation. And similarly, electromagnetism in technology. So how this wireless power transmission? Yes, we are using nowadays we are using wireless power transmission, like for example TV remote. I'm just simply pressing here pressing here particular remotes by simply sitting on the sofa, but the TV will be some Android TV, there will be at somewhere else at wall, fixed at wall. So simply I am pressing the remote, the signal will be transferred to the particular TV, that is through this type of electromagnetism. Simply same thing. For example, same by taking a charging from the mobile, charging from the particular adapter which I just clip to the particular board, fix it to the particular electrical socket on the wall. Simply the charging also converted into the electromagnetic waves without using wire. It will be transferred to the particular mobile which I hold in my hand. So simply because of by avoiding wire, that means with wireless the charging also can be transferred. Like this, wireless power transmission enables different transfer of energy without use of physical conductors. So without using the physical conductors, simply electromagnetic compatibility. So ensures different electronic devices can operate near each other without any interference. Like simply we can example Alexa, you can do you can switch on the motor, you can switch off the TV. Like this, you can switch on the fan. So by this ensures different electronic devices can operate near to us, like a Wi-Fi, some range near to us, operate near each other without any interferences, right? Simply. So electromagnetic waves. So what are some electromagnetic waves? Are radio waves, fundamental for telecommunication and broadcasting. Fundamental for what are these radio waves are? So these radio waves are fundamental for telecommunications and broadcasting. Already you know the radio waves, fundamental telecommunications and broadcasting. And simply microwaves, those are long range waves, so utilized in microwave ovens and for long range communications. And for long range communication also microwaves are using, right? In the same way, gamma rays used in medical therapies, and gamma rays mostly used in hospitals, used in medical therapies and exploring the universe. Simply here we are showing electromagnetics. So in different some ways we are showing biotech and wireless communication and propagation, MEMS and microwaves and optical imaging circuits and optoelectronics, quantum optics, Casimir force and heat transfer and quantum information and nano optics, nano antennas, like this. So the real future of electromagnetism here is the future of electromagnetism, which is used in quantum electrodynamics. Advances in understanding quantum instructions may lead to revolutionary technologies. And similarly, nanotechnology, they are very simple small chips we are using for the memory allocation, like this. So utilizing electromagnetic properties at the nanoscale for innovative applications. Innovative means some new and different ideologies, utilizing electromagnetic properties at the nanoscale, in the nanoscale for innovative applications. And fusion energy, yes, you can see the fusion energy, fusion and fission in the at the sun are like this. So harnessing electromagnetism to achieve sustainable, so that means sustainable which is not collapsed, it will be ever available. Those are some sustainable, I can